In today's video, I'm going to be making potassium iodide from the reaction of elemental iodine with a hot concentrated solution of potassium hydroxide. So on the left here I have 5 grams of iodine, and on the right is 2.2 grams of potassium hydroxide, the stoichiometrically equivalent amounts. So the first thing I'm going to do is dissolve the potassium hydroxide into solution. And hopefully I shouldn't need to worry about heating this, because the reaction of the hydroxide with water generates quite a bit of heat on its own. And sometimes it's actually enough to boil the water. So that's heating up quite a bit nicely on its own, so I shouldn't have to do any supplemental heating. I lost a couple of pieces here. Okay, that's all dissolved and the solution is fairly warm. So I'm going to add the iodine rather slowly so you can see the reaction take place. So now you can see bits of iodine dissolving in the solution. And you can watch the color sort of dissolve away into solution. So it turns out the small quantities that I use mean that I'm going to need to heat this a little bit more than I thought. So I've put it above my gas burner, and we're going to continue adding the iodine to the solution. It has to be hot, otherwise the reaction takes much longer and might not actually go to completion. So again, you can see the iodine sort of spread out on the bottom, and as the solution is swirled, it disappears, more or less. Alright, now we're nearing the end of the reaction, as you can see by the precipitate forming of potassium iodate. Potassium iodate is largely insoluble in water, whereas potassium iodide is very soluble in water, so they're fairly easy to separate, and that's what I'll be doing in the next step. But first, let's add the rest of the iodine. You can also tell you're nearing the end when you mix it and the color persists for quite a while longer. If I've calculated and measured everything correctly, this color should totally disappear as all of the iodine is used up. Well, I've dissolved all of the iodine, and as you can see, I went a little bit too far, added too much iodine. So the solution is very colored, it's full of iodine. That's easy enough to fix by just adding a bit more potassium hydroxide, a few more flakes of that. Oh, and you can hear how exothermic the dissolution is. And you can see as that dissolves, the color clears right up. Well, I've got the solution about as colorless as it's going to get, I think. So I'm going to immerse it in the ice bath for a bit and let the rest of that come out of solution. And actually, now that I think about it, the color is probably due to the iodate precipitate just floating around in there. So once that settles out, I think everything is going to work out nicely. So as I said, we'll let this sit in the ice bath for probably 15-20 minutes, and we'll see how it looks after that. Alright, this thing is cooled down enough, and now I'm going to filter off the remainder of the precipitate. And you can see that some of it is settled on the bottom as well. So that's where most of the color was coming from. So we'll mix that back up again and pour it through the filter paper. And you can see, as I thought, that's removed most of the color from the solution. So now we should have a fairly pure solution of potassium iodide with the potassium iodate precipitate trapped in the filter paper. So now I'm going to take my filtered solution of potassium iodide and boil it down to crystallize everything out. In lieu of boiling stones, I'm using a short length of glass tubing that I had lying around, because it's generally a good idea to have something in there so that to prevent something called bumping, where the solution just suddenly boils and it can throw some of the liquid out of the glass, and it's even doing that a little bit still, but having something with a rough surface in there usually helps to prevent that. So as I said, this is the potassium iodide solution, and what I filtered out of it is potassium iodate, which I have here in the filter paper. Again, I believe that's supposed to be white, but due to iodine contamination, it's going to be a little tan. And what I've found from working with iodine compounds is that generally you're going to have to deal with a little bit of iodine contamination no matter what you do. So things that are supposed to come out clear are generally going to be tan or gray or something. So here's my final product of potassium iodide crystals. I boiled most of the solution down to get this powder, and I let the rest of it evaporate on its own. Despite what I said earlier about contamination, this looks pretty pure. It's a really bright white. Came out looking pretty nice. And as I said, I boiled the solution to get that powder, and I let the rest of it crystallize on its own. And here's the results of that, which came out to be really interesting, actually. They're these really big square crystals, sort of like table salt. Probably because it's actually pretty similar to table salt. Regular salt is sodium chloride, so it's an alkali metal and a halogen, and it's the same thing for potassium iodide. So my guess would be that's where the similarities come from. Thanks for watching.